If some question has haunted scientists the most, it is definitely this one. What is light? Until now, we do not have a single answer for this question. The reason is very obvious. Because few properties of lights are there where light behaves as particles, whereas few properties are there where light behaves as wave. For example, you can see the phenomenon of light like interference or diffraction, which can only be explained by the wave nature of light, whereas the phenomenon like photoelectric effect, Compton effect, Raman effect can only be explained by the particle nature of light. It was Isaac Newton who first said that light behaves as a particle and light is nothing but a stream of particles. He named those particles as corpuscles, and he also said few properties of these corpuscles in his corpuscular theory of light. He tried to explain few very common phenomenon of light like reflection and refraction by his corpuscular theory of light. But the theory failed. Although this theory existed for more than 100 years, people believed that light stream is nothing but a stream of particles. But this theory failed. In few assumptions, Newton said that when light travels from rarer to denser medium, the speed of the light in denser medium is greater than that of the rarer medium, which was experimentally proven to be wrong. Another scientist was contemporary to Newton. He was Huygens. He believed light behaves as a wave. Light is nothing but a wave. He also gave his wave theory of light, but at the time, definitely Newton was very much popular than Huygens, and people started believing his corpuscular theory. Then one experiment came by Thomas Young, the double slit experiment. The double slit experiment could not be explained by this particle nature or corpuscular theory of Newton. And again, Huygens' wave theory could only explain this principle by certain modifications. And after that, photoelectric effect came. And again, people were shocked because this photoelectric effect could not be explained by this wave nature of light that was just postulated by few scientists. So at the end of this, all these experiments, Einstein said that light possesses dual nature. That means in few experiments, we can treat light as particles, whereas in few experiments, light behaves as a wave. So in this chapter that we are going to study, it's called geometrical optics. We will assume light moves in a straight line. Basically, all these phenomena that we are going to study in this chapter called reflection and refraction mainly, these reflection and refractions can be definitely explained by the wave nature of light also. But for simplicity of calculation, for analysis purpose, we will assume light travels in a straight line. So the now question is, when can I assume light moving in a straight line and when I can assume that light has its wave nature? The answer is that whenever light interacts with some device, with some experimental setup where the setup device has a length much bigger than the wavelength of light, which is in order of 10 power minus 5 centimeter. Then we can neglect the finiteness of this wavelength of light and we can assume light moves in a straight line. And whereas the experiment setup itself has a dimension which is not negligible compared to the wavelength of light, like interference or diffraction, we have to assume that light behaves as a wave. So in this chapter, whatever we will study, it can be explained by wave nature of light also, but for simplicity, we assume light moving in a straight line, and that straight lines are called light rays. So this chapter, which I say is geometrical optics, is sometimes also called as ray optics or ray optics. Before proceeding further, I would like to mention 4 important properties of light rays here. So what are those important properties of light rays that I will note here? Properties of light rays. The first property that we will note is in any homogeneous medium or transparent medium, in any homogeneous transparent medium, light travels in a straight line. Number 2, when two light rays intersect, they do not interfere. They do not interfere. What is interference? That we will study in the next chapter, wave optics. But they will not interfere. To understand it, we can say that the rays travel independently. Third property of light ray is when reversed, a ray retraces its path. That means if a ray was moving in this direction and if you reverse the direction of light ray by placing a mirror here, the light ray will move in the same direction or it will retrace its initial path. And fourth property, which is very important, also known as Fermat's principle. Fermat's principle. All the laws of reflection and refraction can also be explained by this principle. It is a very simple and very important principle which says between any two given points, light ray travels in a path that takes minimum time. It's also called the law of least time. So between any two given path, if light ray has to travel, it will always choose that path which takes minimum time to reach. So all these 4 properties are very important to remember. We will keep these properties in mind whenever we will study properties like reflection and refraction. So in next chapter, we will start our discussion with plane mirror reflection. Thank you.